In the long pause between fire and breath, when the earth had learned to be still, something waited beneath the surface of a shallow sea. The water held no color yet, only light, pale and persistent, falling through centuries without witness. Somewhere in that endless noon, the planet rested. Stone settled into stone. Tides rose and fell with the rhythm of a sleeping heart. And in the quiet, time itself seemed to forget what it was counting. This was the age that left almost nothing behind. No mountains thrust upward to mark the passing of epochs. No great extinctions carved their names into the fossil record. The continents drifted, yes, but so slowly that even the patient ledger of geology struggles to read their motion. For roughly 1 billion years, long enough for stars to be born and fade, the Earth appeared to be holding its breath. Scientists call this span the boring billion, though the name betrays more about human expectation than planetary truth. Because something was happening in that stillness, something the rocks remember only in whispers. The light moves gently across ancient water. If emptiness could be alive, what would it dream about? If a planet could rest, would it still be changing, cell by cell, tide by tide, in ways too subtle for stone to record? These are the questions that rise from the 1 billion years no one remembers, not because they were empty, but because they were patient. And patience, in geologic time, looks like nothing at all. Most geologists place this span between roughly 1.8 and 0.8 billion years ago, though the boundaries blur like watercolor at the edges. By then, the Earth had already endured its violent youth. The early bombardment of asteroids had ceased. The core had cooled enough to generate a steady magnetic field. Oxygen, that toxic miracle, had begun to accumulate in the atmosphere through the slow work of cyanobacteria, tiny organisms that learned to turn sunlight into chemical energy, and, as waste, exhaled the gas that would one day fill lungs not yet imagined. The planet had entered what some researchers call a state of stasis, though even stasis is never truly still. The continents during this age were gathered into a single massive landmass that geologists name Rodinia, meaning motherland in Russian. Evidence suggests it formed through the collision of smaller continents over hundreds of millions of years, their edges crumpling and fusing like slow-motion clay. Rodinia stretched across much of the globe, a vast expanse of barren rock beneath an atmosphere that would have tasted bitter to modern tongues. No forests softened its surface. No animals moved across its plains. The land remained naked stone and dust, unbroken by root or wing. Around this supercontinent, the oceans held their ancient chemistry. The water was not yet the vibrant blue we know. Satellite images of that Earth would have shown seas of rust red and green, stained by dissolved iron and thick with bacterial mats. These mats, called stromatolites, grew in shallow tidal zones, building layer upon layer of mineralized sediment. They still exist today in a few rare places, living fossils that bridge the gap between then and now. During the boring billion, they dominated the shorelines, their domed shapes rising like breath from the seafloor. Noon holds steady over green water. Yet, for all this apparent activity, the geologic record from this period is strangely muted. Tectonic activity seems to have slowed. Evidence from rock formations suggests that volcanic eruptions became less frequent, less violent. The recycling of Earth's crust through subduction zones, the great engine that drives mountain building and continental drift, appears to have entered a lull. Some studies propose that the planet's internal heat engine was cooling, causing a temporary slowdown in the convection currents that churn the mantle. Others suggest that the assembly of Rodinia itself created a kind of thermal blanket, trapping heat beneath the supercontinent and creating a temporary equilibrium. The atmosphere, too, seems to have stabilized. Oxygen levels rose to perhaps 10 or 15% of modern concentrations, then plateaued. Carbon dioxide fluctuated within a narrow range. The climate remained relatively warm and stable, without the dramatic ice ages or hothouse conditions that would bookend this quiet era. It was as if the planet had found a balance point and decided for 1 billion years to rest there. But rest is a relative concept on a living world. In the oceans, life continued its invisible work. Single-celled organisms drifted through the water column, evolved, divided, died. Somewhere in those depths, the first stirrings of complexity may have been taking shape. The earliest experiments in multicellularity, the tentative cooperation between cells that would eventually lead to everything with a spine, a leaf, a thought. The fossil record from this period is frustratingly sparse, preserving only hints, carbonaceous films that might be ancient algae, chemical signatures that suggest the presence of eukaryotes, cells with internal structure and complexity far beyond their bacterial ancestors. Scientists believe that this was the age when sex evolved, not as passion or reproduction in the way we understand it now, but as a mechanism for genetic exchange, a shuffling of DNA that allowed organisms to adapt more quickly to changing conditions. Though conditions, during the boring billion, were changing very slowly indeed. And perhaps that was the point. Perhaps what looks like stagnation from the outside was actually preparation, a long accumulation of evolutionary tools that would only prove their worth later when the Earth began to shift again. Everything waits. Beyond what the data can show, there are only the questions that stillness raises. The rocks are silent about the quality of light during those afternoons that lasted 1,000,000 years each. They cannot tell us what the wind sounded like moving across continents without soil to rustle, without leaves to turn. The chemistry is preserved, the isotope ratios locked in ancient minerals, but the texture of existence, the felt sense of a world in waiting, remains beyond recovery. We know the composition of the atmosphere, but not the color of the sky at dawn. We can trace the drift of continents, but not hear the slow groan of their motion. Some researchers propose that the boring billion was a necessary pause, a gathering of resources before the explosion of complexity that would follow. Life, in this view, was not stagnant, but preparing, building the cellular machinery that would allow for true multicellular organisms, animals, plants, fungi, to emerge. The genetic toolkit was being assembled piece by piece in the bodies of organisms too small to fossilize well, too fragile to leave more than chemical traces in stone. Others suggest something more humbling, that the Earth was simply being itself, following the logic of its own systems without regard for narrative arc or dramatic tension. The boring billion was not a prelude or an intermission. It was simply what happened. A planet cooling, continents drifting, tides rising and falling with the same patience that mountains would later show while eroding grain by grain into the sea. There was no waiting because there was nothing to wait for. Only the endless present of geologic time, where 1,000,000 years is a reasonable unit of measurement and change is always happening too slowly to see. And perhaps this is where the imagination must enter carefully, with respect for the boundary between what can be known and what can only be felt. Perhaps the Earth during those billion years was like a held breath before speech. Perhaps the oceans were dreaming in their own chemistry, rehearsing the shapes that would later swim through them. Perhaps the bacteria exchanged their genes like rumors, passing information across the generations with such fidelity and such error that eventually something new could emerge from the endless iteration. The light pauses, or perhaps it is more honest to imagine nothing at all, to accept that vast stretches of time are genuinely empty of drama, that significance is a human overlay we place on processes that have no agenda. The Earth was warm, the continents drifted at the speed of growing fingernails. The sun rose and set billions upon billions of times. And nothing in particular happened, because nothing in particular needed to happen. The universe is patient enough to accommodate long spans of apparent emptiness. It does not require every moment to be eventful, yet even in accepting this emptiness, there is something compelling about the scale. A billion years. Enough time for an entirely new species to evolve, spread across the world, build civilizations, and then vanish so completely that no trace remains. And for this to happen hundreds or thousands of times over, enough time for stars visible in Earth's sky to be born, burn through their fuel, and collapse into darkness. Enough time that if consciousness existed anywhere in the cosmos during that span, entire histories of thought and culture could have risen and fallen while the Earth simply continued its slow chemistry. The fossil record from this period preserves hints that tease more than they satisfy. Structures called Grapania spiralis appear in rocks roughly 1.4 billion years old, coiled ribbons of organic material that may represent some of the earliest large organisms, though what they were exactly remains uncertain. Some paleontologists interpret them as ancient algae. Others suggest they could be trace fossils, the preserved tracks of organisms moving through sediment. The truth is locked in compression and mineralization, in the transformation of living tissue into stone through processes that preserve shape but erase detail. Meanwhile, in the chemical realm, researchers have detected biomarkers, molecular fossils, that suggest the presence of complex organisms. Stiranes and hopanes, the molecular remnants of cell membranes, appear in rocks from this period, hinting at the existence of eukaryotes even when their bodies left no direct fossils. It is detective work of the finest grain, reading histories written in the arrangement of carbon atoms, in the ratios of isotopes that shift when living things process their environment. Dusk settles over the ledger of stone, and beneath these technical details, beneath the data and the careful hedging of scientific language, there persists a kind of poetic possibility. What if the billion years were not boring at all, but simply incomprehensible at human scale? What if the planet was experiencing its own form of consciousness during that time? Not thought as we know it, but the vast distributed awareness of chemical systems in equilibrium, of tectonic plates sensing each other's pressure, of oceans responding to the pull of a moon that was closer then, that raised higher tides, that gradually slowed Earth's rotation from 20-hour days toward the 24 we know. The indigenous concept of deep time, found in various forms across cultures, suggests that the Earth itself is a keeper of memory, that stone and water hold knowledge in ways that transcend human language. In this view, the billion years are not forgotten, because no one was there to remember them in the human sense. They are held in the patient archive of geology, in the layered testimony of rock. Every ancient seabed now lifted into mountains, every grain of sand, once part of a mountain, now resting on a beach. The planet remembers through transformation rather than preservation. When stone forgets its shape, does it still remember heat? When an ocean evaporates and falls again as rain a million years later, is it the same water? These are not scientific questions, yet they circle the same mystery that the boring billion poses, the relationship between change and continuity, between the event and the aftermath, between what happens and what is remembered. Some creation myths speak of a time before time, a period when the world was forming but not yet fully awakened. The dream time of Aboriginal Australian tradition describes an epoch when ancestral beings moved through a still forming landscape, their actions creating the geography and the laws that would govern existence. While these traditions do not map directly onto geological ages, they share something with the boring billion. A recognition that there are periods of becoming that do not fit the scale of human narrative, that require different language, different patience. The human mind struggles with truly long durations. We can say a billion years easily enough, but we cannot feel what it means. Even skilled geologists must resort to metaphor and compression, collapsing the entire history of Earth into a single calendar year, where the boring billion occupies roughly 3 months of late summer into autumn. But even this compression falsifies because it makes the time seem finite, manageable, when the actual experience of those billion years, if experience is the right word, would be an endlessness beyond comprehension. The stars wheel slowly overhead, and in that endlessness, small changes accumulate. a mutation here, a chemical pathway there. The slow drift of continents creating new coastlines, new ocean currents, new climatic patterns at scales that make human climate change look like a weather report. The extraction of carbon dioxide from the atmosphere by weathering rock, the deposition of carbonates on the seafloor, the slow chemical dance that regulates planetary temperature across timescales that dwarf our own capacity for causal thinking. Perhaps what the billion years teach us, if they teach anything, is humility before duration. That history is not only the story of dramatic turning points and revolutionary changes, that sometimes the most important developments happen in the spaces between events, in the long preparation that makes later flourishing possible. After the boring billion ended, though even this is a gradual transition measured in tens of millions of years, something remarkable began to happen. The supercontinent Rodinia started to break apart. Volcanic activity increased, the climate became more variable. Ice ages came and went, and in the oceans, suddenly, the fossil record blooms with diversity. The Ediacaran period, starting around 635 million years ago, preserves the first large, complex multicellular organisms, strange, frond-like creatures that some researchers place outside all known kingdoms of life. These were followed by the Cambrian explosion, roughly 540 million years ago, when most major animal body plans appear in the fossil record within a geologically brief span. Eyes evolved. Predation became a dominant evolutionary pressure. The arms race of survival began in earnest. All of this complexity emerging from a foundation laid slowly and invisibly during the billion years that came before. It is impossible to say with certainty what specific evolutionary advances occurred during the boring billion because the organisms were too small, too soft, too rare to fossilize well. But the genetic evidence suggests that crucial innovations were happening: the origin of sexual reproduction, the development of multicellularity, the evolution of cell differentiation, allowing different cells in an organism to specialize for different functions. These are not small achievements. They are the prerequisites for everything that followed, for kelp forests and coral reefs, for dinosaurs and redwoods, for brains capable of wondering about the billion years that preceded them. And so the emptiness was never truly empty. The silence was never complete. In the chemical patience of single-celled life, in the slow cooling of the planet's interior, in the drift of continents and the fall of rain on barren stone, something was always happening. It simply happened at a scale that defeats human intuition, in a register we are not designed to perceive. The Earth was composing itself, cell by cell, element by element, through trial and error conducted across spans of time that turn evolution into something closer to chemistry, to the inevitable sorting of stable patterns from chaos. Darkness gathers at the edges. We, who live in bodies shaped by that long preparation, who breathe the oxygen those ancient bacteria produced, who walk on continents that drifted during those slow centuries, we are the answer the boring billion was quietly working toward, though we were not its goal. There is no goal in geology, no purpose in plate tectonics, only the relentless logic of physics and chemistry playing out across a sphere of rock and water cooling in the vacuum of space. And yet, there is something beautiful in the lack of drama, in the long faithfulness of planetary systems that continue functioning whether watched or unwatched, remembered or forgotten. The tides that rose during those billion years felt no different to the moon than the tides that rise today. The sun that warmed those ancient seas did not know it was shining on an age that would leave almost no record. Existence continued, indifferent to significance, patient in its own unfolding. When we look back now at the boring billion, we see it through the lens of everything that came after: the riot of Cambrian life, the greening of continents, the rise of intelligence. We cannot help but read it as prelude, as the slow first act before the drama begins. But perhaps that is our error. Perhaps each moment of those billion years was as complete and sufficient as this moment, as any moment. Perhaps the bacteria photosynthesizing in shallow seas, the minerals precipitating from solution, the slow weathering of granite into clay. Perhaps all of this was not waiting for anything else. Perhaps it was simply what it was, the earth being earth, time being time. In the deep ocean trenches that we still cannot fully explore, there are creatures living at thermal vents, deriving energy from chemicals rather than sunlight, existing in a darkness that has persisted for millions of years. Some scientists believe these environments are similar to the conditions where life first originated, and that similar organisms may have existed during the Boring Billion, their lineages stretching unbroken across that vast duration. They would have experienced no boredom, of course, no sense of waiting or anticipation, only the perpetual presence of metabolism, of molecules transforming into other molecules, of energy flowing from chemical gradients into the patterns we call life. The night settles completely now, and in that settling, in the release of the need to understand or explain, there is a kind of peace. The billion years remain largely mysterious, and perhaps that is as it should be. Not everything can be known, not every age leaves clear testimony. Some spans of time pass quietly, their significance felt only in what they allow to follow, in the foundation they provide for later complexity. Like the long hours of sleep that restore the brain for waking thought, the Boring Billion may have been the Earth's own rest, not inert, but regenerative in ways too slow and too deep to track. We are made of elements forged in stars that exploded before the Boring Billion even began. We stand on continents that drifted during that slow age. We breathe air processed by organisms whose ancestors lived through every moment of those billion years. The forgotten time is not separate from us. It is woven into the very substance of our being, the deep inheritance we carry without knowing its story. And so we return to the beginning, to the shallow sea and the pale light falling through centuries without witness. The water still holds that same patient chemistry. The light still touches the surface, though the surface has changed beyond recognition. The earth keeps breathing in its own timescale. Mountains rise and fall, species come and go, and somewhere beneath it all, in the slow turn of continents and the patient work of erosion, the planet continues its long conversation with time. The question was never whether anything happened during the billion years no one remembers. Everything happened. Every tide, every sunrise, every molecular transformation that moved life one infinitesimal step toward complexity. The question, perhaps, is whether happening requires witness, whether time without memory is still time, whether a billion years of patient chemistry matters if it leaves almost no trace. The rocks whisper that it does, that even silence is a kind of speaking, that even stillness is motion at a scale we cannot see, that the Earth's memory is deeper than human forgetting, written in languages we are only beginning to learn to read. And in the end, as the script of time winds down toward sleep, what remains is simpler than any explanation. The mystery itself, the wonder of duration, the humility of accepting that some questions cannot be answered because they are not really questions at all, but invitations to rest inside the unknowing. The light fades to darkness. Everything settles. The earth breathes on.